All right, families of quadratic functions. What we've seen so far is that there are three different forms of a quadratic function. We first looked at the vertex form, which is in this form right here, and it's called vertex form because it tells you exactly where the vertex is located. The h value and k value tell you the coordinates. The factored form we also looked at, so this is when your trinomial is fully factored with perhaps a common factor in the beginning. So remember that the x-intercepts happen when y is equal to 0. So if you put 0 in the place of y, you can then solve the equation, and r and s become your x-intercepts. So the factored form tells you the x-intercepts. And remember, you can also figure out where the axis of symmetry is if you know the x-intercepts. It's right in the middle of those two intercepts. And then you can use that to find the vertex as well. Look back at your notes to see an example of that. There's also the standard form when it's just fully expanded out. And this tells you the location of the y-intercept. And very quickly, the y-intercept happens when x is equal to 0. So if you sub in x is equal to 0, this is 0, this is 0, so you're left with c. So that final term is the y-intercept. Now what these three all have in common, they all have this a value here. And remember, a is the vertical stretch or compression factor. So we had our set pattern when we used the vertex form of 1, 3, 5 would get multiplied by a. That is the same with all of these forms. So if you know where the vertex is, you can use the set pattern multiplied by a to place the rest of your points. So all those different forms give us different types of information. What we're going to be looking for here is we want to put together, using the information given here, we want to put together what the equation of the parabola would be. So if a parabola has x-intercepts of positive 6 and positive 10, and also passes through this point, now remember that equations can be used to give you an x value and y value for any point on the parabola. We want to determine the equation. Now, we're told what the x-intercepts are for this parabola. So which of the forms that I went over on the previous page would be most useful to us? So that would be the factored form, which I have conveniently copied here already. So what we know, we actually already know what the r value is and what the s value is. So the equation will look like x minus 6 times x minus 10. Now the problem is right now we don't know what the a value would be. What would be the multiplication factor for the step pattern? So here's what we can do. This point of 3 and positive 42 is on the parabola somewhere, and that gives us an x coordinate and a y coordinate. So I can substitute in that y is equal to 42, and that happens when x is equal to 3. So by substituting that in, we're now going to have an equation that I can solve for what a is. Alright, so to solve this, we'll do this a little bit quickly. 3 minus 6, negative 3. 3 minus 10 is negative 7. So what this means is 42 is equal to a times negative 3 times negative 7. So if I multiply both of those, I would get 21a. So if 21a is equal to 42, divide both sides by 21, and we will get the a value is 2. Alright, so now we know that the step pattern would get multiplied by 2. This will give me my final answer. I want to write down what the equation is, remember. So I'm just going to draw a line to separate my work here. So y equals 2 times x minus 6 times x minus 10. So again, we use the factored form because we're told the x-intercepts, and that's when the factored form would help us. So substituting those x-intercepts into the factored form, I can then substitute this point, x and y, for my x and y variables, and then solve for what a is. Alright, so here's another style of question. A parabola has a vertex of 1, 6 and passes through the point 4, negative 21. Determine the equation. So we're told what the vertex is, so which of those three forms of the equation would be useful to us? So, well, easily enough, the vertex form is helpful when we're told what the vertex is. Now remember, with the vertex form, the vertex tells you what h and k are. Excuse my screen shifting there. And it also passes through the point 4, -21. So remember, when we're told what a point is on the parabola, that gives us an x value and a y value, an xy coordinate pair that belong to that parabola. So I can substitute in all 4 of those variables. And remember, we still don't know what a is. Just like the previous question, we have to figure out what the a value is. So -21, I'll put in for y. That was my y coordinate, is equal to, we got a times x minus h. So x is 4, subtract h, so subtract 1 squared, plus k. Just remember that it is x minus h squared. So if h is positive 1, remember that moves the vertex to the right by 1. So it actually looks like -1 in the brackets. Just be careful of that. All right, so just remember order of operations. So brackets first, 4 minus 1 is 3. After we figure out brackets, I know that I do exponents, so 3 squared is 9, so I have 9a plus 6. So I just want to solve for a here, so the 6 needs to move over to the other side. So that'll be -27 by subtracting 6 is equal to 9a. Dividing both sides by 9, and I get my answer, a is equal to -3. So that means if I were to graph this parabola, the step pattern would have to be multiplied by -3. All right, so again, I want to know what the equation is. Now, when we write down an equation, we don't put in a value for x and y. We leave those as variables x and y because remember, we can plug in any x value that we want to figure out its corresponding y value. So it's just h, k, and the a value that we want to put in. Basically, it should look like a parabola that we would then be able to graph. So for this section, take a look at those 3 forms, the vertex form, the factored form, and the standard form, and try to read the question, and whatever information it gives you, try to substitute that information into one of those 3 equations to then figure out the rest of the information that you need.